right, today we are going to review simplifying radicals so that we can do some other things with them besides just simplify them. And so we're going to start just with square roots, and we'll get to some other vocabulary and stuff in just a minute. But as a reminder, if we have x squared equals 25 and we want to get x, what would we do? Square root. So I'm going to take the square root of both sides. When I do that, what does x equal? Close. Plus or minus 5. Unless you want to go to math jail, it is plus or minus 5. If you introduce the square root in your solving process, you have to put plus or minus, okay? Now, everything else we do today, the square root will already be there, okay? So we don't have to worry about plus or minus. You just do whatever is there. But I like to do this at the beginning so that you don't lose sight of that fact when you end up taking the square root. Okay, so if I have x squared equals 26, when I take the square root, what's the first thing I write down? Plus or minus, before I worry about anything else. Is 26 a perfect square? No, it is not. So it's really just plus or minus the square root of 26. I can't do anything else with that, and that's fine. I don't want the decimal, I want it in exact form, okay? Now, when you simplify square roots, there are different ways to do this. I know some of you may have learned the birthday cake, which I've known at one point, but I don't really know what that is. I just know it's a thing. And if you don't know what I'm talking about, it's okay. But, and that's fine and that works, okay? And even if you've learned to take the biggest square root that divides into the number and figure that out, that works. But that's not necessarily the best way when we're looking for stuff other than just square roots. If we want cube roots or fourth roots or fifth roots or stuff like that. So in my opinion, the best way to handle this so that it works for everything is prime factorization. Thank you. Okay. And prime factorization is actually something you did in elementary school. So without square roots, let's just talk about what that means. So let's take 45. And we're going to find basically all the factors of 45. So you can start with, what are two numbers that multiply to give me 45? 5 and 9. Okay. So I got a 5 and a 9. So we're making a little factor tree. When you get to the end of a branch and you have a prime number means it's divisible by what? 1 in itself, and that's it, right? So when I get to a prime number, I'm going to circle it. That ends that branch. 9 becomes 3 and 3. Okay? So that is my prime factorization. 3 times 3 times 5 equals 45. If you can do that, you can do all of the rest of this. All right? Now, that's not actually simplifying anything. That's just, again, old school prime factorization. So if I give you something like the square root of 27, and now, and sometimes you might just know them, and that's okay. If you're good at it, you can just, you don't always have to go through all the steps. But what are two numbers that multiply to give me 27? 9 and 3, okay? Or 3 and 9. It doesn't matter what order you put it in. And sometimes we have options, and you can use different options than me. Then 9 becomes 3 and 3. Because this is a square root, you are looking for pairs. So I'm going to take these two 3s. They get to come out of the little house as a regular 3. This guy's by himself. He has to stay in. And it's 3 square roots of 3. Okay? To check yourself, you can square what's on the outside, multiply it by what's on the inside, and you should get that back. Okay? All right. Everybody good with that? Does it look familiar? Or at least, and again, if you want to do the birthday cake or you have another method, I don't care. But what I am suggesting to you is looking for the biggest perfect square is not necessarily the best way, because if I give you square root of 336, what's the biggest perfect square that divides into there? Tell me now. That's what I thought. I don't know either. Well, I actually do know because I've already worked this question. But if it takes you in, if you don't just know, do not waste a single second on that. It's not worth your time. Start just dividing it out. Is this divisible by 2? Yes. Is it divisible by 3? Yes. Which one might be easier to do? 3. I would think 3 on this one, but again, it's a matter of opinion, and it doesn't matter which one you do first. Let's divide this by 3. If I take 336 and divide it by 3, what am I going to get? 112. Okay. Is 112 divisible by 3? No. But is it divisible by 2? Yeah, and not too bad, right? What would that give me? 56 and 2, or 2 and 56? Again, does not matter what order. What are two numbers that multiply to give me 56? 8 and 7. Remember that 5, 6, 7, 8, right? 7's a prime number. 4 and 2. Let me scroll a little bit so I can. Oh, maybe not. Sorry. And then 2 and 2. Okay. And so you want to circle the prime numbers so you know where the ends of your branches are, right? Now we start looking for pairs. This 3 does not. This 3 does not have a pair, so he's going to have to stay under. I'm going to mark him out as I use them. This 2 I can match up with this 2. Since I have a pair, he gets to come out. The 7, there's only one of them, so he stays inside. These two 2's come out as a 2. Everything gets multiplied, and this is 4 times the square root of 21. That's my answer. Okay. Now, the biggest perfect square that divides into 336 is 16. But I think the great majority of us wouldn't know that without some guessing and checking, and I don't think it's worth your time to guess and check when you can just make the tree. Okay? So just, because you're not going to have to do this a ton. If you know how to make the tree, just make the tree the whole way, move on with your business. Okay? We good with that? Questions? All right. What if I gave you 4 times the square root of 48? Okay? If you have something that's already out there, this guy just sits and waits. He just sits and waits. Okay? 4 just sits out there. So I'm basically going to ignore the 4 at the beginning. Start with the 48. What are two numbers that multiply to give me 48? 6 and 8. Earlier today, the first thing I heard was 4 and 12. Does not matter which one you pick because your tree will look different, but in the end, you'll have all the same numbers. 6 would be 2 and 3. Those are prime numbers. 8, 4 and 2, and then 2 and 2. Okay, everybody good with all of those? Okay, so what we can't do is we can't forget about this guy. He's already out there waiting on us, right? These two 2's, and it's okay that they weren't next to each other, but I'm going to mark them out as I use them. They come out as a regular 2. These two 2's come out as a regular 2. This does not have a pair. He stays inside. So this will give me 16 times the square root of 3. Okay. What questions do you have? We good on that? And if we can do that, then it works with cube roots, fourth roots, whatever else. Okay? All right. So on the other side, we're talking about square roots and cube roots, but then we also have fourth roots on here. But you have a radical sign. That's your root, right? Inside is the radicand. The number right here, this is called the index. The index tells you what kind of root you have. So that is a cube root, Gael. That is a cube root, but I can also talk about it as being a third root. Okay, sit up, put something you can write with in your hand and write this down. Right, so for a square root, like what we just did, you must have 2 of the same number or variable to take the square root or to take it out. When we have variables in here, a perfect square for variables is when the exponent is divisible by 2. For cube roots, you have to have sets of 3 of the same number or variable, and then a perfect cube is when the exponent is divisible by 3. Okay? So my suggestion on how to work these is to start off exactly like how we've been working the rest, and we pay attention to the number in there first and kind of ignore everything else at the beginning. So we're just going to look at this 24, okay? Just the 24 right now. Two numbers that multiply to give me 24. 6 and 4. Okay. So then that 6 can become 2 and 3. 4 can become 2 and 2. Okay. So I'm going to take care of all this stuff first, this number stuff first. I have two 2's that can come out as a regular 2. I'm going to leave a bunch of room here, and then I have a square root. The 3 stays inside, and the 2 stays inside. Okay. Then I look at the rest of the stuff. So I took care of the 24. I've got this x squared. You look at the exponent. The index here is 2. If you see nothing, it's like it's a square root. We know that there's a 2 there that we just don't write. Kind of like you don't put the 1 in front of the x. So x squared, I take that 2 that is the exponent, divide it by 2, and that just means a plain old x gets to come out. Then I have y to the 6th. I take that 6 divided by 2, and I get y cubed. So I've now taken care of the 24, the x squared, and the y to the 6th. But I'm taking the square root of a negative number, so what does that mean? What do I get? I. This I comes out here. So my actual answer is 2xy cubed I times the square root of 6. Yes and no. His question was, does it matter where we place the I? This is where you will normally see it. If you put it somewhere else, it doesn't mean that it's wrong. It's just kind of the proper way. Like, wouldn't it be weird if we did xy cubed times 2? Like that, at this point, that just kind of seems weird because we're used to the numbers coming first. Because it's like the proper way to put the 2 out front. So it's the proper way to put the I here, but it wouldn't be wrong if it was somewhere else. What I suggest to you, though, especially if it's a handwritten answer, always put the square root last, so there's no question about what's underneath the square root. Because sometimes your roots might get a little crazy and you can't tell if you meant for it to be underneath or not. And so it's just safest for that to be at the end. Does that help? So, good question. Anything else? All right, so now let's look at number 2. We have a 3 right here. Our index is 3. That does not change how we start. So we're going to start with just the 81. That's 9 and 9. Then that becomes 3 and 3 and 3 and 3. Okay. Now, we all know that the square root of 81 is 9, but we don't care right here, right? Because we're looking for the cube root. So now I look for sets of 3. So these 3 3s get to come out as a regular 3. This 3 doesn't have 2 little partners, so he has to stay inside. So this is a cube root right here. Just leaving myself some space. Okay, we good? All right, so now I look at the x cubed. That exponent is 3. I take 3, divide it by 3. It divides evenly, and that's a 1, so it's just an x that comes out. Then I look at the 6. 6 divided by 3 is 2, and it's exactly 2, so all of my y's come out, but it's y squared. Then I have z to the 11th. 3 does go into 11, but not evenly, right? So 11 divided by 3, how many times does 3 go into 11 evenly? 3 times, right? So if I was going to divide like 3 into 11, it's 3, and then my remainder is what? 2. So that means this is z to the 3rd, but I have 2 left over, so those have to stay inside. Okay? Everybody okay with that? All right, so now I have this negative. Is this going to have an I in it? It is an odd root. So think about this. What is negative 1 times negative 1 times negative 1? Negative 1, right? So the cube root of negative 1 is negative 1, where the square root of negative 1 is I. If you have an odd root, the negatives are okay, because negative times negative is a negative. So my odd root, if there's a negative inside of here, the negative just comes out. Because negative 1 times negative 1 is positive, times a negative is a negative. So this is the key right here, is when I take the cube root of a negative, I get an actual real number. It's negative. I can't take the square root of a negative. That's why I get I. because it's an even root. Okay? Uh-huh. Not the same thing, because the fourth root of I, that would really just be this, that would end up being the square root of I, which is weird. You're not going to have to deal with those, I don't think. Just worry about the square roots with the I's. That's a good question, though. But everybody good on that? So odd root, if it's negative, is just negative on the outside. Just pull the negative out with it. And then I didn't have to clean this one up at all. And be careful that your indexes, especially like when it's typed, it looks all nice and pretty. When you're writing it, don't confuse yourself and think it's an exponent or think it's something else, because I've seen that a lot too, where we just confuse ourselves with what we wrote. Ask me questions. Anybody got questions? All right. So now we're moving on to 3, and we are going to start off the same way, just looking at the number 32. Two numbers that multiply to give me 32. 8 and 4. 4 can be 4 and 2, right? 4 can be 2 and 2, and then 2 and 2. Okay. So since I have the fourth root, I'm looking for sets of what? 4. So I take 1, 2, 3, 4 2s. That's a 2. This guy doesn't have 3 partners, so he has to stay in here. Fourth root of 2. All right, so then I look at the x's. Are some x's going to come out? Yes. Are all of the x's going to come out? No. So 4 goes into 10 how many times? 2. So this is x squared. And then I have how many left over? 2. 4 goes into 15 how many times? Evenly. 3, with how many left over? 3. It's a coincidence that those are the same numbers every time there. And then 8 divided by 4 is what? 2. So all of my z's come out, and that's my answer. Questions? It doesn't look real pretty, but is it crazy difficult? No, you got this, right? Okay. So number 4, we start the same way, just by looking at the number. 4 and 2. And then this 4 is 2 and 2. All right. I'm looking for sets of what? 2. Okay. And listen, don't forget about this guy. So I got this 3x out here that's already there. Then these 2 2's come out as a regular 2. This guy has to stay inside. And then what comes out for x? X squared. What comes out for y? Y. What all stays in here? Just y. Everybody okay with where all that came from? And then I just got to clean it up. That'll give me 6x cubed times y times the square root of 2y. You got lost? Oh, no. Okay. Are we good? Okie dokie. Now, on 5, we're going to start by putting what this does not equal. This does not equal x plus the square root of 6x plus 3. So write down what it doesn't equal, because you do not get to just take the square root of each little piece. It does not work that way, whether there's 2 terms or 3 terms. It works on all the rest because it's all multiplication. That's addition. That's a no-go. All right? Instead, what we actually get is that I can't just take the square root like it is, but can you factor what's inside of there? Yes. So go ahead and factor what's inside of there. The 9 is positive, so the signs are the same. The 6 is positive, so it's plus and plus. What are my numbers that multiply to give me 9, combine to give me 6? 3 and 3. So is there another way to rewrite this? X plus 3 squared. There you go. Square root of x plus 3 squared. And if you take the square root of something that is squared, they basically just cancel each other out. And your answer is x plus 3. Okay. What questions do you have? Anything? All right. Good deal. So your assignment is in Delta Math. I have to go click a button first, but it's in Delta Math. You got lots of time to work, so get on it. Ask me questions, use your notes, use each other.